Chemical tests for sulphite. Sulphites are compounds containing sulphite ions. In the sulphite ion, the sulfur atom is doubly bonded to one oxygen atom and singly bonded to other two oxygen atoms. There is also a non-bonded lone pair of electrons on the sulfur. Sulphites are often used as preservatives in dried fruits, preserved radish, and dried potato products. Our aim here is to test the presence of sulphite ion in a given salt. The tests to determine the presence of sulphite ion are preliminary tests and confirmatory tests. The preliminary tests are dry heating test and dilute sulfuric acid test. Dry heating test. Materials required: original salt, test tube, acidified potassium dichromate paper, test tube holder, and Bunsen burner. Procedure: take a small quantity of the salt in the test tube and heat it over the Bunsen burner. On heating, sulphite undergoes decomposition to evolve colorless sulfur dioxide gas with a characteristic suffocating smell. Place an acidified potassium dichromate paper over the mouth of the test tube. In presence of acid, sulfur dioxide reduces chromium in potassium dichromate from +6 to +3 oxidation states. Chromium in the +3 oxidation state gives green color to the acidified potassium dichromate paper. Dilute sulfuric acid test. Materials required: original salt, dilute sulfuric acid, acidified potassium dichromate paper, test tube, and a dropper. Procedure: take a small quantity of salt in the test tube. To this, add a small quantity of dilute sulfuric acid using the dropper. Sulphite reacts with dilute sulfuric acid to form colorless sulfur dioxide gas with pungent smell. Place an acidified potassium dichromate paper over the mouth of the test tube. In the presence of acid, sulfur dioxide reduces chromium in potassium dichromate from +6 to +3 oxidation state. Chromium in the +3 oxidation state gives green color to the acidified potassium dichromate paper. Next, we look at the confirmatory tests of sulphite. The confirmatory tests are barium chloride test, potassium permanganate test, potassium dichromate test. Barium chloride test. Materials required: aqueous solution of the salt, barium chloride solution, dilute hydrochloric acid, test tubes and droppers. Procedure: take a small quantity of aqueous solution of the salt in a test tube. To this, add a small amount of barium chloride solution using a dropper. Sulphite reacts with barium chloride to form a white precipitate of barium sulphite. Take a portion of the precipitate in another test tube. To this, add a small amount of dilute hydrochloric acid using a dropper. Shake the test tube. The precipitate of barium sulphite dissolves in dilute hydrochloric acid to form soluble barium chloride and evolved sulfur dioxide gas. Potassium permanganate test. Materials required: precipitate of barium sulphite, acidified potassium permanganate solution, test tube and a dropper. Procedure: take the second part of the white precipitate of barium sulphite obtained in the barium chloride test. To this, add a few drops of acidified potassium permanganate solution using the dropper. The pink color of potassium permanganate is discharged because in presence of dilute sulfuric acid, sulphite reduces potassium permanganate to colorless manganese salt and sulphite undergoes oxidation to form sulphate. Potassium dichromate test. Materials required: aqueous solution of the salt, acidified potassium dichromate solution, test tube and a dropper. Procedure: take a portion of the aqueous solution in the test tube. Using the dropper, take a small amount of acidified potassium dichromate solution and add it into the aqueous solution. In presence of acid, sulphite reduces chromium in potassium dichromate from +6 to +3 oxidation states, and sulphite undergoes oxidation to form sulfate. Chromium in the +3 oxidation state gives green color to the solution. Precautions: handle the apparatus and chemicals carefully. Use droppers to take the reagents from the bottles. Wear a lab coat and gloves while performing the experiment.